The first one that we're going to talk about is if you have a triangle and inside that triangle, two of the sides are congruent. If these two sides are congruent, the angles opposite those sides, so angle B and angle C, have to be congruent as well. And the shortcut that we're going to use, congruent sides implies congruent angles. Or if you do the pictures, that's fine. Congruent sides implies congruent angles. Add those to your shortcut sheet. The opposite of that is true as well. If I have a triangle and I know that two of the angles are congruent, the sides opposite those angles, so here and here, are congruent as well. So if I have congruent sides, that implies I have congruent angles. Or if you want to use the pictures, that's fine. Congruent sides implies congruent angles. Add those to your shortcut sheet as well. Okay. We're going to spend a little bit of time talking about proving that we have isosceles triangles. One way to prove that you have an isosceles triangle is if you have two sides that are congruent. So if I have two sides that are congruent, that implies I have an isosceles triangle. Or you can write it out, two sides congruent implies isosceles. And if I have two angles congruent implies I have two congruent sides, which means I have an isosceles triangle. So two congruent angles implies isosceles, or if you would like to write it out, two congruent angles implies isosceles. We need to put that and that onto our shortcut sheet as well. All right, the inverses of these statements are also true. Remember, the inverse, that's where you add the knots. So if you have two sides of a triangle, and those sides are not congruent, so something that looks like this, and this side is not congruent to that side, this angle is not congruent to that angle. And kind of going along that same road, if I have a triangle and this angle is not congruent to that angle, then this side is not congruent to that side. We aren't really going to use these in our proofs, but it's still just important to see that. Okay, whenever you have a triangle, the larger the angle, the longer the side that you have that it's going to open up to. The smaller the angle, the smaller the side that it opens up to. And the way I think about it, if you open your arms up, the angle created here, as that angle gets larger, the side, the space between my fingers, gets bigger. The larger the angle gets, the bigger the space between the sides, the space between my fingers. If I start to make the angle smaller, the side, the space between my fingers, gets smaller as well. So the larger the angle, the larger the side that it opens up to. The smaller the angle, the smaller the side that it opens up to. Okay, I already told you that an equiangular triangle and equilateral triangle are the same things. The reason why, if I know that GH is congruent to GJ and congruent to HJ, if these angles are congruent, then we just talked about if the angles are congruent, the sides are congruent, then the angles are congruent. So if this side is congruent to this side, these angles are congruent. If these sides are congruent, then these angles are congruent. So since all three sides are congruent, all three angles are congruent. The book's going to use those interchangeably. So if you see one, if you see equilateral, you know it's also equiangular, and vice versa. We cannot apply these to other shapes. We can only apply these to triangles. So for example, if I'm looking at this shape, if I'm looking at the rhombus, a rhombus is equilateral. All the sides are the same, but all of the angles are not. In a rhombus, those are congruent, and those are congruent. And if I have a rectangle is equiangular. All of the angles are the same, but all of the sides are not. So we can only apply those two theorems to triangles. We can't apply them to other shapes. All right, proof time. So I know that angle 3 is congruent to angle 4. I know that BX is congruent to AY. And BW is congruent to AZ. All right. I'm trying to prove that triangle WTE, so triangle WTZ, WTZ is isosceles. And I have two different ways to do that. If I want to prove that triangle is isosceles, I need to either prove that those two sides are congruent, or I need to prove that my two angles are congruent. Well, looking here, I'm probably not going to try to prove that these sides are congruent because I don't know anything about BT or TA or the relationship here. I don't have midpoint, midpoint, bisect, bisect, trisect, trisect. So I'm probably not going to say that my sides are congruent. So I need to find a way to say that angle W is congruent to angle Z. And I'm going to try to say that by saying that this triangle is congruent to this triangle. I already have side, side. So I can either go for side, 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 or go for side, angle, side. I'm probably not going to use side, side, side because I don't know anything about WX or YZ. So that one's out. I'm going to try to do side, angle, side. So side, angle, side, side, angle, side. I need to prove that these two angles are congruent, which I can do. These two angles are supplemental. These two angles are supplemental. So since these angles are congruent, those have to be congruent as well. So I'm going to go ahead and do that first. So angle 3 is supplemental to angle WBX. Straight angle implies supplemental. Angle 4 is supplemental to angle ZAY. ZAY. Same reason, straight angle implies supplemental. Now I can say that these two angles are congruent. Angle WBX is congruent to angle ZAY. They're supplemental to congruent angles. Implies I have congruent angles. Now I can say that my triangles are congruent by side, angle, side. So triangle WBX is congruent to triangle ZAY. And if those are congruent, then I know that angle W has to be congruent to angle Z by CPCTC. And if these angles are congruent, if I get rid of all the other stuff, what I have is TWZ And if angle W is congruent to angle Z, that's an isosceles triangle. So triangle WTZ is isosceles congruent angles implies isosceles. Or if you want to write it, two congruent angles implies isosceles. Either one of those are fine. Okay, let's look at another one. All right, so I'm given that angle E is congruent to angle H, and I'm given that EF is congruent to GH. I want to prove that DF is congruent to DG. So let me get my givens in there. Angle H is congruent to angle E is congruent to angle H. EF is congruent to GH. All right. Well, I'm trying to prove this is congruent to that. So if I can find a way to say that this triangle is congruent to this triangle, then by CP/CTC, those would be congruent. If I'm just looking at the picture, if I take away all the other stuff and just look at that one big triangle, triangle EDH, I know angle E is congruent to angle H. And if angle E is congruent to angle H, then ED has to be congruent to DH. Congruent angles implies I have congruent sides. And if these sides are congruent, then my triangles are congruent by side, angle, side. Side, angle, side. So now I just have to put it all into my proof. So the first thing I did was I said that DE is congruent to DH. Congruent angles implies I have congruent sides, which means these triangles are congruent. Triangle DEF is congruent to triangle DHG by side, angle, side, which means that DF and DG are congruent by CP/CTC. Let's look at another one. Okay, so if I want to figure out what side's the longest and what side's the shortest, I've got to go back to thinking about, well, the larger the angle, the larger the side. The smaller the angle, the smaller the side. So my largest angle is 83. So the side across from 83 has to be my largest side. The smallest angle, 33. The side across from that has to be my smallest side. And then my middle angle is my middle sized side. Okay, so here I want to find out what's the measure of angle C, and I want to find out the perimeter of the triangle. First, to find the measure of angle C, if I'm looking at this, I see that these two angles are congruent. If these two angles are congruent, then the size of the sides across from those angles has to be equal as well. So since this is 11, that side's 11. I can find out angle C if I add up all my angles, so 54 plus 54, subtract that from 180, I get 72 degrees for angle C. And then to find my perimeter, I add up all my sides, so 11